All right, here comes your packet work, guys. We are up to 4-5 day one. I had to write it in there. Must have been something wrong with the printer, the way it copied it. But we're up to page 135. And let's go ahead and kickstart this thing. See, I already did this one in the pre-lesson, but that just means go 2 to the right, down 3. That would, and essentially, we're going to consider that as a point, but remember that's also the end of the spinner if you need to go there. But we're just plotting points right now. 1, 1 would be 1, 1. This one's a little sneaky because you have to think of it as 3 plus 0i. So that means go out 3, and then you're not going to go up, you're not going to go down, so it's right there. And this just says go left 2, and then down 1, and there you have it. All right, get the idea? Now's where they're going to start challenging you with a little bit more. All right. So it says find the trigonometric form. I'm going to write that again right above this because I see that it's up top there. Cosine theta plus I sine theta. There we have it right in front of our face. For the complex number, now that means that's written in standard form, where the argument satisfies, and there's that big clue. Your answer that you put in here cannot be negative, and it cannot be greater than 360, so keep that in mind. I'm going to start with this one because it's a little less trickier than that one, and this is a good one to just get started with. So if I start by plotting that point, 4 square root of 3 means go that far, and I'm not going to be perfectionistic about it, but then I need to go down 4, so that's negative 4. And boom. Now, if you guys remember, 30, 60, 90s are always on the prowl. So are 45, 90s. Now, if you see that square root of 3 pop up, what's your instinct? 30, 60, 90 or 45, 90? I hope you're saying this one. Because remember, for this one, the square root of 2 is the magical trigger. So we ask ourselves, is there a triangle out there where one side is the square root of 3 of the other? Yes. That means this has to be the 30, this has to be the 60, and I apologize for drawing it. It looks like a 45, 90, but we'll have to get over that. So if this is 4, notice I'm ignoring the negative for now because I'm doubling it because I know my radius, my spinner, my hypotenuse must always be positive. Now, why am I figuring all this out? Because I need it for this. So this is standard form, and I'm going to put all these clues into trigonometric form. So I'm going to go, all right, z equals r 8 times cosine. Now I can't say 30 because that would mean I flip my spinner up to here. So you got to be careful here. I can't say negative 30 even though that's correct because of that limitation. So I have to ask myself, how far did I spin my spinner? Well, that'd be 330 plus I sine 330. There we go. And that's in trigonometric form. Now let's go ahead and tackle this one because I think it's next on the easy list. And this just says go to the right 4 and then go down 7. I'll make this picture look a little bit more accurate. So that's negative. And then I connect them because really I need that hypotenuse because that's what my r is. It's my radius. This one has no special features to it. There is no connection that I can see, making it a 30, 60, 90 or a 45, 90. So we're just going to go with our good friend, a squared plus b squared equals c squared. That's 16 plus 49 equals c squared. That's 65 equals c squared. Square root of 65. Now, I got to find this. See that? Now, I feel bad putting that there because it's not really what this is going to end up being. So maybe I should have put alpha in there or something, but I'll talk to you about that in a minute. I'm going to take advantage of this being the opposite and this being the adjacent. I'm going to ignore this because I don't like the square root there. And I'm just going to use tangent. So I'm going to use tangent of theta equals opposite over adjacent, which means this is negative 1.75. Now, this is when I have to go second tangent. I got to tell my calculator, hey, Mr. Calculator, I need you to do me a favor. Second tangent, negative 1.75. See, it tells me that theta is negative 60, well, round a little bit, negative 60.3. That cannot be what I put in these spots because there's limitations. I need to put this in those spots. So filling this in, I get r, which is the square root of 65, times cosine. Now I'm going to go 360 minus 60.3, because that's what this is. And that'd be 299.7. So I get 299.7 plus I sine, let's squeeze it in there, 299.7. I did it. A little squirrely 7, but there it is. Okay. Now it's saying, all right, guys, here's your trigonometric expression. Change it to standard. Okay. Well, this is telling you how far to spin your spinner, so that's nice. I'm going to do my, oh, shoot, I forgot letter A. All right. So how do we get started on letter A? Well, this is the same thing as 0 minus 2i, which tells me on my real axis, don't go right or left, but I need to go down 2. All right, now watch this. So this is telling me right away that my r is 2, and if this is my spinner, I spun it 270. And now I'm ready to put things in where it belongs. So r cosine 270 plus I sine 270. All right, there it is. So this one, doing it in a different direction, going from here to here. So this is saying, hey, you got to figure out what the dimensions, the sides of your triangle are. And then, you know, your hypotenuse might help you a little bit. Well, it's going to. So I'm going to try to draw a drawing by squeezing it in here. Start by flipping my spinner to 10, which is right there-ish. But I know that's got to be 30, which is very helpful, because I got a 30, 90, 60 with my hypotenuse 8. Well, how did I know my hypotenuse was 8? Right here. Remember, that's my r, my radius. And if that's 8, this is negative 4. And if that's negative 4, this is negative 4 square root of 3. Which tells me A is right here. So it's negative 4 square root of 3. BI is going to come from here. So that'd be negative 4i. This standard form is the same thing as that trigonometric form. Interchangeable. Okay. Very similar. What's pi over 4? 45. Nice review problem of spinning your spinner from here up 45. Complete your triangle. Well, you've been seeing a lot of this. Here's my radius. See, now is where they're going to mess with you. See, we need this and we need this. Now, yes, they're going to be the same, but if this is a 45, 45, 90, how do I get from there to there? I divide by the square root of 2. Because if I was going the other way, I'd multiply by the square root of 2. But I got to get that square root out of there. So I get 5 square root of 2 over 2. And if that's what this is, that's what that is. I don't need to do it twice. Remember, this is my real component because it goes down along the real axis. This is my imaginary. So it's going to be 5 square root of 2 over 2 plus 5 square root of 2 over 2i. And there it is. There's your standard form. All right. I think that's the hard part. Now, if you look at this, you're like, oh, crap, a whole bunch of more difficult formulas. Not really. Okay? Now watch this. It says, if you're going to take the product between two of these, you simply, and I mean simply, multiply the r's together. Let's stop right there. Let's concentrate on this multiplication thing. You see z1 and z2. We got z1 times z2. Here's my r's. And that says, according to the formula, multiply them together. And now, what's the rest of the formula say if I just keep traveling along this direction? It says it's going to equal cosine. I just add the individual degree measures, cosine of 180, plus I sine, and I got to do the same thing here, 180. Now I could leave it, but it doesn't say leave your answer in trigonometric form, which is what this is. So they're going to make your life a little more complicated. We got to look over here at 180 and remember these really weird rules where my adjacent is the opposite of my hypotenuse, which tells me that my opposite side is 0. And yes, you can check this with your calculator just to make sure your computations are right, but sine would be opposite over hypotenuse, which would just be 0. What's cosine of 180? Well, that'd be adjacent over hypotenuse, which is -1. And I distribute, I get -21. As strange as it is, this thing times this thing gives me a number, -21. Okay? So, now we have to figure out the division part. Now let me get my pretty little markers out here. So, where's the division come from? Right here. What does it say to do with the r's? Divide. The first one divided by the second one. So I'm going to go like that. Now we're going to find z1 over z2 and just follow the formula. A lot of formulas, but don't be intimidated by them. So we take the first one, divide it by the second, and now we subtract. Cosine, the first one minus the second one, which would be 120, and then plus I sine, and then it'd be the same thing. 150 minus 30 is 120. And now if they said leave it in trigonometric form, we could be done, but it's going to say simplify it. So we got to know what 120 looks like. So that's 90 plus 30. Here's my 90, here's my 30, and I finished my triangle, so this is 60. I'm going to make this one -1. This is my square root of 3. That's my 2. So I get 7/3. What's cosine of 120? Adjacent over hypotenuse. What's sine of 120? That'd be opposite over adjacent. So square root of 3 over 2i. And if I distribute, I'd get -7/6 plus 7 square root of 3 over 6i. Standard form, trigonometric form. Don't know if I have time for this last one, but I'm going to try to squeeze it in with less blah, blah, blah. So, multiplication, just multiply the r's. So I'm finding z1 times z2. Multiply, 15. Now, I need to go cosine. Whatever I put here is going to be the sum of these two. Now, most students like to convert this to degrees. So pi over 4 is 45. Pi over 3 is 60. Times 5 is 300. And so that'd be 345 plus I sine of 345 because the rule is the same. So hold on a second. So 60 times 5, 300, 345. Yeah, 345. Okay. Maybe they haven't been asking us to put this in standard form. I'm not sure because this one, if I went 345, it goes like that. We'd have a 15-degree angle here, and I think they're going to let us leave that. I think. But it doesn't really say up here to leave it in trigonometric form or put it in standard, so I apologize if I've done too much with these answers. It's very likely that I did. It could be very likely that this is my answer for this one. This is my answer for this one, but I demonstrated how to keep going if they ask us to put it in standard form. This one's a little wonky. But let's go ahead and go z1 over z2 and follow. It's not an I, it's a 1. So, first thing I do is I divide. So 5 divided by 3 is 5/3. And I have to be careful here. I subtract, the second one from the first one. So that'd be 300 from 45. So what's 45 minus 300? Would be -255. So I'd get cosine of -255. That's not minus, that's the negative.